Okay, this is question number 3. If you haven't already watched the videos for questions 1 and 2, go back and do that first, please. Then come and have a look at this one. So, referring to a previous video then, this time I'm actually going to draw my diagram down here, okay? I don't feel that by trying to put lengths on this thing here, it's all just going to get too messy for me. So I'm making the decision, you can decide whatever you want to do, that it won't take me very long to do the new beam, the new rod, the new whatever, and it's really important that I get the lengths right on my one. So let's just have a quick read through of this question. It says, a beam of length 5 meters, yeah, okay, they've got that. I'm looking straight away to see is it uniform or not. Yes, it's a uniform rod. Right, so straight away I know that the mass is convecting in the middle. Lies on a horizontal step with end A on the step and end B projecting over. Right, so here's my rod. And what this means is that we're going to have a pivot around about there. This is the reason for doing past paper questions. You might not have seen a question like this before, and you need to see all the different things that they could ask us to do. Edge of the step is at the point where dB equals 1.3, yeah, fine. Small boy stands on the beam at C, can see that. Beam is on the point of tilting. Boy is modelled as a particle, beam is modelled as a rod. Find the mass of the beam. Okay, so I'm not going to read the rest of the question here. I know the rest of the question, almost certainly from my previous experience, will be a new diagram. So let's just crack on with this first bit then. So I've got my rod here, which is going from A to B. I know it's pivoted about this point D here. And they gave me some lengths that I could put on. So I know that all of it is it's 5, but that means that my weight, what was my weight? 30. No, he's 30. I'm going to call the mass M. Is that what I'm trying to find? That's what I'm actually trying to find. So I'm going to call that mg there, and I know then that that length is going to be 2.5. I know that this distance here is 1.3, which means then that this total distance here is 3.7, which then means that that bit there is 1.2 when I'm doing it, okay? I may as well put my reaction force on while I'm working out the other lengths. I've got that the boy is going to be at C here. And what's he? He's 30G. And that gave me, this length was 0.5. If the total length is 1.3, then this length here is 0.8. Now that took me a couple of minutes more maybe to draw out than trying to draw it on top of the original diagram. But I'm now much happier in terms of being able to work out what I'm going to be doing and how I'm trying to work this out. Okay, so if I'm looking at this one, we know the options we've got. I know I can say, if I want to, that R is equal to mg plus 30g, and I might need that later on, but I'm actually just looking at this first bit and saying, do you know what? I can do this straight away because it's such a simplistic diagram that if I decide to take moments about here, the only two forces I've got are the mg times 2 and the 30g times 0.8. So I'm almost doing that in my head first, just taking an extra couple of seconds, keeping nice and calm with this one, and then saying, well, that gives me the answer straight away. So I'm not going to do that extra work at the moment. You know, in effect, I took my extra time to be able to draw my diagram out properly. So now, actually doing this bit, I just need to tell the examiner what I'm doing. So, taking moments about D. Takes an extra few seconds to write that in, but it's absolutely worth it now. And now what have I got? I've got mg times 1.2 is equal to 30g times 0.8. And the only thing I don't know there is the m. So as with all the other ones, I'm not going to do all the work that you need to rearrange that. It's a very, very simple rearrangement, and I'll get that m works out to be equal to 20 kilograms. Okay, so now I can look at part B. I haven't really read for part B yet. but I'm pretty certain that I'm going to be changing my diagram in some aspect. And again, that's the reason why it's not worth drawing your diagram there, because what would you do about putting this next part on now anyway? Let's read through it. Block of mass X is now placed on the beam at A, okay, and when we do that, can you find the smallest value of X that will enable the boy to stand at B without the beam tilting? Okay, so when we're looking at that one there, when we look at that one there, that's just going to be a new diagram. Sorry, I'm just reading the rest of that part again. So draw my diagram out again. Okay, I've got AB here. I've still got my pivot acting at point D there. So I'm still going to have a reaction force acting there. And what I've got now is that that's going to be XG there. This hasn't changed. That's still 20G there, with that being 2.5 and that being 1.2. So those things haven't changed at all. If this one moves to the end there now, I can actually put that as just being 1.3 and leave it as 1.3 in there. So once again, if I'm looking at that, the only things that I haven't got are here and here. There would be a slow version of doing that is equal to those ones and then do something else, but it's a nice easy question, this one. If again, I just take moments about that, I can see before I even get started that I've got that one times that, well I've got both of those, that one times that, and X is the only thing I haven't got, that one times that, so X still is the only thing I haven't got here. So I can take moments about D again. Take moments about D. And when I'm doing that, let's just be careful with what I've got. So it's X G times 3.7 plus 20G times 1.2 is equal to 30G times 1.3 there. Okay, if we get that, then I'm not going to bother doing all the recalculations and everything. We'll just get that X works out to be equal to 4.054, which is 4.1. Does it say to? Yeah, it doesn't say the decimal place or significant figure, so I'm doing it to 2 there. The G's actually cancel, so you could do it more accurate than that, but 4.1 would be enough as far as I was concerned to be able to do that then. Part C, it's one of our classics. It says, show how you've used the modelling assumption that the block is a particle. Well, for all those people that were in the lesson last, pretty much the penultimate lesson that we did, I wrote all of these out for you. So, if, who is it that's acting as a particle? If the block is a particle, if the block is a particle, and then this is what they want, the mass acts at a single point. And that bit there is what I'm looking for my answer. Mass acts at a single point. Okay, hopefully that makes sense. One thing I did not mention, but that's just because I just did it automatically, was when it says it's on the point of tilting, then obviously we're going to get that we're able to take the moments about D. So I just didn't mention that part. Okay, hopefully that makes sense.